Let's choose a hypothesis test to use with this research question. In 2013, 46% of employed Americans said that basic mathematical skills were necessary for their job. A researcher wants to know if the rise in technology has caused that number to increase. In a random sample of 150 employed Americans, 87 reported that basic mathematics was necessary for their job. The first thing we notice about this question is that it says 46% of employed Americans. That's a percentage, which is a clue that we want to test a percentage or a proportion, which is an indication that we should consider using a 1 proportion z-test or a 2 proportion z-test. To decide between these two types of tests, we want to look at how many samples or groups are involved in the question. Here we have one sample of 150 employed Americans, out of whom 87 said yes to the question, are basic mathematics necessary for your job? The value from 2013, the 46%, was given without a sample size. So we need to treat it as an established fact. That means that our hypotheses would look like this. The null hypothesis is that the proportion of all Americans who say that basic mathematics is necessary is 46%. And the alternative hypothesis is that that proportion is greater than 46%, because the researcher wants to know if the rise in technology has caused the proportion to increase. So here we have one sample and a null hypothesis that pi, a population proportion, equals some number. That's an indication that we should consider using a 1 proportion z-test. Next, we need to check whether the validity conditions are met. Recall that the validity conditions for a 1 proportion z-test are at least 10 successes and at least 10 failures. So if we go back to the statement of the problem, we see in a random sample of 150 employed Americans, 87 reported that basic mathematics was necessary for their job. So we have 87 successes and 150 minus 87, or 63, failures. Both of those are greater than 10. That means that a 1 proportion z-test is appropriate.